I'm starting the recorder. Okay. Alright, so for chapter 7, kiddos, direction of factor.
I'm going to do a test.
Alright. Let's be serious about it. Alright, here we go. We're going to go ahead and work on factoring. So we're going to start, we are in chapter 7, I'm going to go here in my iPad since it was working great now. There we go. Should be coming back up. Alright, kiddos. Factoring, the name of the game is we want to get to parentheses. I'm going to move this down. I'm actually going to go ahead and just erase all of this since we've done some examples yesterday, or we did some examples yesterday. Let me go ahead and get into factoring for right now. Okay, I'm going to show you guys today the X method. Some of you have seen this before and some of you have not. Okay? We're going to start with number 9, then number 10, then number 11. I think out of these three, the hardest one is number 11. Out of these three, I would believe the hardest one is number 11. Okay. Number 10. Number 10 is a little bit easier. And then number 9 is the easiest out of all of them. The X method says, ready? For number 9. Do you guys remember how once upon a time we had a little table and we talked about factors of, and technically it would be the last, and then we talked about sum to the middle. Factors of the last, we tried to cut up the last number into its factors. For instance, for number 9, we would say factors of 50, 1 and 50, 2 and 25, 3 doesn't go in, 4 doesn't go in, 5 and 10, etc. If I were you, I'd be practicing factoring. It's a very tricky topic. Everybody else, here we go. Number 9. Angel, you ready?
Yes.
So, we would talk about factors of the last, which would be like 50 in number 9. Sum to the middle, which would be adding to 15, or I should say negative 15. Okay? The X method is a little different, but it still does the exact same idea. For number 9, the X method says if we have the problem which we see up above, S squared minus 15s plus 50. The X method says take the last number, which is usually the first thing we would do in the table, and write it at the very top. John, you have it. You can be resting your hands when you do this. The last is going to be on top. The middle number is going to be on bottom. Now, technically on top, we actually multiply the first times the last. So 1 times 50 gives us the top number, and negative 15 just gets us the bottom number. So I'm going to go ahead and, because technically for harder problems it changes a little bit, I'm going to go ahead and say 1 times 50 goes on top, 15 goes on the, goes in the bottom. And what we're looking for, guys, is 2 special numbers. And we're going to write those 2 special numbers right here in the middle of the X. We're looking for 2 special numbers that multiply to be 50 and add to be negative 15. Looking for 2 numbers that multiply to be 50 and add to be 15. So, yeah, some of you are helping. We can just start writing 1 and 50 is a no, right? 2 and 25, and it's gone again. 15. We're trying to look for ones that add or subtract to be 15. 1 and 50. Let's try and repeat for effort. You guys randomly think about the math department. I mean, in general, this summer, hopefully not all bad thoughts. You can just be like, Lord, you can help the school to get their computer stuff all together. Yeah, big expensive. Okay, I'm going to do this. So, S squared. Plus 50. How did I make my X kiddos? What did I put in the top?
50.
50.
50
50, yeah. We multiply the 1 and the 50 for the 50 up top. And then what I put in the bottom of that?
Negative 15.
Negative 15. Some of you were trying to help me, and some of you might have already gotten there. We're trying to break down 50. So we had 1 times 50. Did that help? No. 2 times 25?
No.
Plus, if you add them, 27. If you subtract them, 20.
5 and 10.
3 doesn't go in 4, doesn't go in 5 and 10. Does that help?
Yes.
How?
Because.
5 times 10 is 50, but 5 plus 10 is positive 15.
Yeah, but both negative.
Now, hold on. Shouldn't we already have known both negatives? If the last sign is positive, the sign
Doesn't change.
Stay the
stays the
same.
same.
Darn it.
Okay, if the last sign is positive, the signs stay the same. If the last sign is negative, those signs, they must change. Got it. So the last sign is positive, the signs stay the same. But I had a negative number, hence why I made them both negative. Now, whenever there is a 1 in front, the special numbers that we find form our factors. And if you notice, it's shorter than making a table and writing words. So we can just say s minus 5 and s minus 10. Once again, this is a shortcut to the table. Still use the idea of factors of this one that add to this one. It's just, for most of you, a little shorter to write in the table. Now, this one was nice and easy because what was in front of the s squared for the quadratic?
1.
It's not going to be quite as easy in number 11, but hopefully we'll get to do number 10 first, and that'll review what we need to do the shortcut in number 11. Okay, any questions on number 9? Any questions on?
So basically you find the multiples of
Factors
factors of, is it the biggest number or just
of the last. Well, technically it's the first times the last. So see how I multiplied 1 times 50 is 50. So I'm breaking that number down.
And then once you break that down, that's
One of them hopefully adds or subtracts to the other. That's your perfect. Now, if the what am I trying to say? If the trinomial starts with a 1, it's as easy as taking those special numbers, which we found to be, again, negative 5 and negative 10, right? Adding to be negative 15, multiplying to be positive. And we can go straight to 1s and 1s. We know both the signs are negative, and we have 5 and we have 10. Okay? Now, what's different, though, when we look at number 10 first? We have to figure out 10 before we can figure out 11. How many terms does number 10 have? 4. Now, whenever there are 4 terms, we don't want to use the x method. That's for factoring trinomials. Whenever we have 4 terms, we need to think about grouping. So I'm going to go ahead and write grouping just so that we can be thinking of grouping. You might not remember it, but grouping says you have to put in parentheses. So I have my h cubed. I have my 2h squared minus 9h minus 18. 4 terms, it's more than we're used to. It's more than we're used to. So the grouping says, okay, hold on, it's too big, we've got to break it down. And to break it down, we can do the following. We can put parentheses around the first 2, plus parentheses around the last 2. Now, I have not factored. All I've done is grouped a couple terms together with a plus in between. That's not the final answer. The final answer has no plus in between with factoring. This is the first step. I'll do 4 terms. I cut them up into pairs. Now, we look at the pairs separately and say, is there anything in common, of the first 2, is there anything in common?
H2.
Exactly. H, not just 1, but h squared.
H squared.
So I'm going to pull out an h squared.
What happens to the h?
Let's think about it. Remember, we're pulling away h squared, not subtraction, division. So if I say h cubed is h times h times h, and I take away 2 of them, h squared, what's going to be left over?
Just h.
Just h plus, this is 2 times h times h. If I take away h times h, what's left? Just the 2. So we have to think about these in their elemental pieces, and there's just an h left in that factorization, and there's just a 2 left in that factorization. What's in common? Have you guys already seen? And the
9.
second pair.
Minus 9.
Negative 9 is in common. No h's because only one of them has an h, only one term. So we pull out a negative 9. Exactly. Think of negative 9 times h. Take away the negative 9. You're dividing it. What's
H by
left?
itself.
Just the h.
H and 2.
And then think that negative 18 is 2 and 9 with the negative. If I take away the negative and the 9, what's
It's going
left?
to be positive 2.
Positive 2. Good job, good job. So what do you notice about each of these?
Same.
Now do you remember what we do? It's kind of one. You take it out. You say, hey, each of these pieces has an h plus 2. So I take out and I take away what was common. And if I take away the yellow circle, what's left in each of the
H
pieces?
squared minus 9.
Good. Now, if we're going to write this a little bit prettier, we would go ahead and say we have h plus 2 times h squared. Now, this one's a little crazy. This is maybe a little bit advanced because we're not technically done. Does anybody know what's so special about what we call a difference of squares? A square minus another square. Very.
You need to simplify it.
How?
That's the formula.
Yes.
A plus b times a minus b equals to a squared minus b squared. So it's
I'm going to go ahead and show what Barry did. Give me 1 sec so they can follow along. Some need to see it. A plus b times a minus b is a squared minus b squared. And this is what you see here. So Barry, what are you going to end up factoring? This one stays the same, right?
h plus 3
Good.
Yeah, h plus 3 times h minus 3.
Good. What he's saying is, hey, I saw this pattern of a squared minus a squared. So I'm able to go back to what it factored to be. It's what we call difference of perfect squares from chapter 7. So we can actually break down h squared minus 9 to be h plus 3 h minus 3. This one was kind of crazy. We could go one step further, but we have finally gotten down. There are no more squares, no more common factors. Everything is no pluses or minuses in between. We're done. We have our factors.
I don't know why, like, you put parentheses on why.
Because this one made one parenthesis. This one was still squared and could factor down
You
even
have to
more.
get rid of the square.
Basically, if possible. And remember, if you want, you can always double check by, how do we multiply these? How would we double check that I did that, Angel, correctly? Everyone else, how do we multiply? By numerals? Starts with an F and ends with an
Oil.
Oil?
oil. First,
Soil.
what's after first? Because I did h times h is h squared.
Negative.
How do you spell foil?
Oh.
F-O. What's O stand for?
Outer.
Outer, which is going to be negative 3
H.
h. Keep spelling foil.
Inner.
Inner.
Plus 3.
Inner is going to be,
Minus
Minus
9.
9.
what happens to these two? So was I right to say that h squared minus 9 comes from h plus 3 h minus 3?
Mm-hmm.
Yes. One of those special ones. It's okay, but I was right. And Barry was right as well. That was a good catch. Okay, coming back. So we reviewed foiling, we reviewed factoring, and why did I want to do number 10 before 11? Well, it comes first in the review. But also, it talks about grouping. Guess what we need to know for number 11?
Grouping.
Grouping. In order to use the X shortcut method, we need to use grouping. I'm going to go ahead and iPad real quick, add a new page because I'm running out of room. Let's look at number 11. Last question from chapter 7. We have the trinomial, negative 5k squared minus 22k plus 15. Okay. And I showed you just a second ago that x shortcut to the table method. Some of you guys are like, yeah, the table. Okay, so the table taught us factors and sums. Factors, we're breaking apart numbers into their factors. Sums, we're trying to add the two factors. Okay, what did I tell you, or how did I tell you to fill in the table on top? What goes in the very top, sorry, the x on top? Careful. The 15 times what? Some of you got it, some of you forgot.
5.
Okay. Not the k, just the numbers. Negative 5 times 15 ends up being negative 75. Okay? Now, what goes in the bottom of the x? What goes in the bottom of the x? Here. What goes in the bottom of the x? Those aren't paying attention. What's the number I have? No, I used 15
22.
times 5. That made 75. But I haven't used the middle number. 22, I think. Let's double check the problem.
Yeah, I think that's 20.
Yeah, 22. Okay. Now, question. If there are any factors of negative 75, you gotta break them down into factors. What's negative 75? Yeah. 25 times 3. Is that a good one or a bad one? Should we keep going? Sure. Just think about positive 25 plus 3. 28, no. But what's 25 minus 3?
22.
Oh, but wait. That's positive 22, but it is a 22. How do I make it a negative 22? If the 25 is a negative and the 3 is a positive, hold on. What's a negative times a positive?
Negative.
And what's negative 25 plus 3?
Negative 22.
Yeah. Those are our numbers. Now, here's the crazy part. Does this trinomial start with a 1?
No.
So I'm trying to show you how to use the x to solve the crazier ones. To solve the crazier ones, we use these special numbers, but we can't go straight to the answer. We say we know where this negative 22 came from. He came from negative 22k. He came from negative 25k, and he came from 3k. You guys see where I got each of those numbers, first of all. So I steal the negative 25 and the 3. Why did I put k's in there?
Because it's 22k.
It's a k term. Yeah, it's a k term, and there is a k squared saying we have a k and a k. Okay, so if I broke up the negative 22, wait, that's not the only thing though. That's just the middle term. What did I have at the very, very beginning? Well, I broke up the 22. He's been dealt with. So negative 25 plus 3k is negative 22k. But what else do I have in my trinomial? What was the first term?
5, negative 5.
Good, negative 5k squared. And what's the last term?
15, plus 15.
Plus 15. So check it. I kept the first, I split up the second, and I kept the last. Question, how many terms do we have now?
4.
What can we do whenever we have 4 terms?
Separated by 2.
What's it called? The word I highlighted. The last
Spoil.
Grouping.
Grouping.
Grouping, I'm pairing them up. So grouping, pairing them up. Jordan and Tyler. Grouping, I'm pairing them up. So I'm going to put parentheses and parentheses. Make sure there's a plus in between. Good. Now remember, I'm not done. This is a step. The question, is there anything in common here?
Negative 5. Negative 5.
Negative 5 and a k. If I pull out a negative 5k, now remember, negative 5k squared is negative 5 times k times k.
Yeah.
If I take away a negative 5 and a k from the factors, what is left?
1.
K.
No, k.
1k.
1k.
1k. 1k. This one would be, I'm looking at my numbers, negative 5 times 5 times k. If I pull away the negative and the 5 and the k, what's left?
Positive.
Yeah, divide.
Positive.
Positive 5, not a 4. positive 5. So I'm going to have 1k left over and a 5. Remember, you can distribute and double check. The first one would be negative 5k squared. The second one would be negative 25k. Now, we need to ask ourselves the same question. In the second group, is there anything in common? Okay, but yeah. A 3. So, what happens when we factor out a 3? If we pull away a k
K
plus 5.
we have a k. And then if we pull away, well, 3 times 5 is 15. Take away the 3, there's a 5 left. What do you guys notice after we did group?
They're the same.
And what can we do if they're the same?
Combine them. Like, yeah.
Basically, yeah, pull it out. Take out the k plus 5. Say they both have it, we'll pull it in front.
What happens to the negative factor?
Well, we haven't dealt with them yet, so yeah, that's the good point. If we take this out, remember we're factoring, pulling it out. If we take that out, what's left? Negative 5k, and what's left?
Plus 3.
We're taking away the k plus 5 from each of them, and we end up with negative 5k plus 3. There it is. Now, we're going to go a little prettier. We're just going to
What do
say,
you turn to k squared? No.
well, remember we're trying to break apart the quadratic into linear factors. There we go.
So you're gonna have a couple issues for every chapter.
Every chapter is going to be represented in the final, yes. 2 questions? No, we have way more than 2.
No, I said a couple.
That's
See, alright.
It's okay. You meant.
So on third.
Hey.
Have you part this?
No, Rob, you're good. Some people say a couple of minutes. Just say Yes.
Questions from each.
yes. About each of these.
Thank you.
Alright, cool kids. That was chapter 7. Factoring is not easy, but it is possible. Do you want me to give you just a random easy one and see if we can do it with the x?
Yes.
Okay. So we've been doing some hard ones. Let's do one more easy one. What if I was to give you the following? This is just be an extra example. Don't shout out the answers. Let everyone try. But what if I was to give you g squared plus 7g plus 12. And the directions were to factor. Give everyone a second. Make your x.
We do this on the homework paper?
Yeah, you can. Make yourself an x. I'm not going to solve. I'm just making sure you're making the right x. What are you guys putting in the top?
12. And 1 times 7, so 7 because at the bottom.
No, just take the middle. Don't multiply by anything. A, Rob, and J. I'm not sure exactly what you're doing. I'm pretty sure not all 3 of you are caught up to chapter 7 and 8 then. Say all 3.
I'm not sure.
Does anybody tell me how many factors it's solved that way?
4.
Good. I'm seeing a lot of you guys. 3 and 4. So, question, what's the number in front? Do we like them? Can we go straight to the answer or do we have to do group? So we can say, no adding. What are my final factors?
G plus 3, G plus 4.
Now kiddos, I'm going to ask you one thing. This is also in chapter 7. What if I put an equals 0 in there? I factor this, and we have, but what if there's also an equals 0 that we have to deal with?
Both?
Set them both. What are them both? The factors?
Yes.
Good.
And you put
Set each factor
equals
what?
0. Each one.
Good. If there was an equals 0, you would go one more step.
Okay, 3 and
You would set each one, good, equal to 0. And then you would solve with algebra. Hopefully some of you would see, hey, subtract the 3, I get negative 3. Or subtract the 4, I get negative 4. Alright, kiddos, chapter 7. Even though that was a quick glance, that was a good glance, and I hopefully gave you some shortcuts whenever you see factoring, or whenever you see solve and no factors are there to begin with. If the factors are there, set each one equal to 0 and solve.
You know, some of like the final possible choice, like with this, so we would have to make sure it's all the way.
Yeah, go right here. Right here, kid. All your stuff. Let's go.
So we have to make sure like we have the answer and like in its little possible term.
Simplify. So like if you got 3/6, the multiple choice would probably have 1 equal to 6.
Yeah.
Not sure why. But if you don't see your head like this, when everything is going on over here. So keep it pointed. We're going to go ahead and go to chapter 8, kiddos. Because we had a few questions in chapter 8 yesterday. From chapter 8. Let me go ahead and show the ones that people asked yesterday, just so we so far have number 4. Do we have any other ones? Yeah, Ron. Okay, so number 1 and 4. Anyone else from chapter 8? Yeah, 8. 5. Jenny. Okay, that's going to keep us busy. So let's go ahead and see if we can get 1, 3, 4, and 5 done today. Now, kiddos, why is chapters 9 and 10 still the homework for tonight, even though it was homework last night? It's difficult, and we got slowed down on questions. So we're not going to get to 9 and 10 today, so you have a little bit of grace. Try to get to 9 and 10 tonight. So you have questions, so we can finish all of our questions tomorrow, the last day of class, okay? So 1, 3, 4, and 5. When we go ahead and look at chapter 8, 1 and 3 both have the directions graph and compare. Wait a minute, what can you put on your card that you're allowed to take and write on 3x5 card?
Formulas.
Yeah.
Formula graphs.
Formulas or the table for the comparing. Remember there was that table with the comparing words of translation, reflection, and shifting, etc. Try to go and move over 2 seats real quick so I can see them. I'll probably go a lot. Okay, so when we go to graph, kiddos, I said, except for lines, y equals mx plus b, where we have special things like start with the b on the y-axis and move the rise over the run. Except for those, I said use a table. I said use a table. So for number 1, I'm going to go ahead and get up my iPad so you can see it. The function is 2x squared minus 3. And it's each of x equals, right? Right away, looking at the function, is it going to be a line? Is it going to be a swoop one way, or is it going to be a parabola? Yes, it is. Yes, it is.
Job around.
I have a question though on HX, which is automatically turn into a Y.
You could think of it as a y, that would make it easier for you.
Y equals 2x squared minus 3. And we just graph it because you're negative 3 over the y-intercept.
Well, not the y-intercept. Yes, you could. But for parabolas, lines, we only need 2 points. Parabolas, we need 3. Yeah, we need to make sure that you have enough to see the full
So
parabola.
it would go up one way.
It could, or it could go downwards. Do you guys remember? Thank you. Do you guys remember how we can look at a quadratic and see whether it's concave up or concave down?
Yeah,
When it
Not the slope.
concave. Oh, that's number.
That's for lines. Nope, not the last number. That's the y-intercept. If the first term is positive or negative.
okay, so
Or A. Remember A, B, C?
if
If
positive is concave.
If A is positive, it's up, which it has a minimum, and if A is negative, then it's down, and it has a maximum. Jay, are you distracted?
No, I.
So as we go ahead and really graph this, Rob already said that we could think about h of x as a 1. We are going to make an xy table.
If you turn it into a Y,
Okay. Kiddos, do you remember the shortcut to find the vertex? Because that helps us make our table. I know, it's been a while. If I were you, remember how I told you the other day? Let's see, what are we writing down?
Oh,
I mentioned the quadratic formula is a good one, but we haven't gotten to that yet. Oh yeah, it was the exponent property. How you can write formulas on your card. Here's another formula that might be good for your card. Okay? The vertex is known as HK, and H is found by using negative B all over 2A, and K is found by plugging in X equals H. Yeah, this is the one with a lot of formulas.
Oh no.
It's okay, you have a formula card, you just have to actually write down the important formula. Do you guys notice at the end of every chapter, in the chapter review, they review all the formulas from that chapter? Would that be a good place to look for your formula card?
When the chapter reviews.
Yeah, at the very end of the chapter. I think it's actually right before the review.
What did you learn?
Yeah, there's always a what did you learn that shows you some of the important formulas and concepts. Then there's the chapter review where they do examples like each. And then the chapter test. So what you guys want to look at probably for your formula card is the what did you learn, which happens
What did
2
you learn?
times. Yep, it happens 2 times every chapter, in the middle and at the end. Alright, kiddos. So, do you remember how to figure out who's A, who's B, who's C from a quadratic?
yeah.
Yes.
They know it. The X.
X equals
No, but what is A, B, and C? Remember? A x squared plus.
B S plus
X
Okay.
plus C.
So question, what is the A in number 1?
2.
A does equal 2 in number 1. What's B though?
0.
Why is it 0?
Because there is no B.
There is no x term. B is 0, but what's C gonna be?
-3.
Good. So B equals 0 and C equals -3. If it helps you, you could rewrite the quadratic to be 0x minus 3. Then hopefully you can see the A, the B, and the C a little bit clearer. So then we can go ahead and ask ourselves for the vertex. Okay. How do I plug into -b over 2a for this
You
one?
put negatives 0.
Yeah, good. All over 2 times 2.
2.
Now, some of you get a little confused on this, but you could also try it in your calculator. What is 0, or even -0, divided by 4? 0. What does that tell me? I need to have a 0 in my table, and I need to have something before, and I need to have something after. Because 0 is going to be, in this case, my minimum. It's my vertex. I need a little point before and a little point after to get a good picture. Now to find k, we got to plug in 0 and plug in x equals h. Plug in what we just found. And we just found h to be what again? So if h is 0, then we're going to go ahead and take our original quadratic equation, which is right up here. And we're going to say it's time to plug it in, y equals 2 times who squared minus 3? 0 squared. PEMDAS says 0 squared is 0. 2 times 0 is 0. So I know my vertex is 0, -3, and I can plug -3 into my table. Now we would have to also plug in a few more points. We'd have to plug in -1 and 1 also. If we were to plug in -1, I'm going to go ahead and show the notation this way. Oh, it's not an F, it's an H, isn't it? I could do H of -1, plug it in, and H of 1, plug it in. 2 times who squared minus 3, and 2 times who squared minus 3. Once again, you guys see where I'm getting this pattern, right? 2 times who squared minus 3. I just got to plug in numbers for x. So plugging in -1 and plugging in +1. We'll have each of our y's for our table. Go ahead and zoom in on these for just a second. PEMDAS says, and it says, do the parentheses, but there's nothing inside the parentheses. Do the exponents Negative 1 squared is positive 1.
Wait, Steve, he said, please excuse my direct sound. What's the name?
Direct south.
Oh, okay.
Direct south.
2 times 1 is 2. 2 minus 3 is negative 1. I found one y value. And then this one. 1 squared is 1 again, minus 3. I end up with 2 times 1 is 2 minus 3 is negative 1 again. So I have in my table a negative 1 and a negative 1. And how are we going to graph it? Leave ourselves an x and a 1. I have negative 1. I have 1. And I have 0. I need to go down 1, 2, 3. 0 needs to have a point at negative 3. Negative 1 needs to have, nope. Yeah, negative 1 needs to have a point at negative 1. 1 has to have a point at 1. At negative 1. Do you guys see your problem? I do. Is it concave up? Does it have a minimum?
Yes.
Number 3. Now guys, I'm not going to go ahead and take tons of time on number 3. It's actually probably a little harder than one that you would see on the final. But you could use the exact same procedure as number 1. As you notice, they were both graphing. I would use the exact same formula for H. I would find K. That would go in the middle of my table. I do 1 point on the left and 1 point on the right. Okay? So let's go ahead and look at number 4, because we got number 1. Number 3 is pretty similar, so I'm going to go ahead and leave him. What was different about number 4? I know we have a couple minutes left. Let's see if we can finish chapter 8 so that we can catch up. Number 4 says, oh hey, we give you a graph, huh? We'll go ahead and not even, oh I guess I could write this in. Okay, so we have to answer these questions, right? So for letter A, domain? Domain, isn't that how left, how right? Why am I going to say all real numbers if how left, how right? Because I'm going to go all the way left, all the way right. So infinity left, infinity right. So for domain, I'll say x is all real numbers. What am I going to say for range? How high does it go? No. How high? Positive 8. Now that's just a blue line. Positive 8. Up to 4, 6, 8. So it's going to be a maximum of 8. What inequality am I going to use to say 8 is below? Good. Less than. Does it hit at 8 though?
Yes, so
I'm
it's
saying
less than or equal to 8.
good. What are my zeros? I'm going to finish this
3
time
and
so you
7.
guys can go. 3 and 7, because that's where it hits the x-axis. How would I write this function in standard form? Nice thing is, guys, for letter B, those of you that got stuck, we actually didn't talk about standard form. So we can cross off letter B. Hold on, pause. We can cross off letter B. For letter C, can anybody see any of those comparative words? We're just finishing this one. Anybody see any comparative words that apply? Shift. It does shift. Where?
Go up 8.
Good. It shifts up 8 and over
3.
Good. So I can say it shifts up 8 and right 5. Is there a reflection? Because usually parabolas are concave up. This one is concave.
Down.
So we can say that there is a reflection, and technically we could say a vertical reflection. And we won't worry about stretch or shrink. It's hard to tell from the picture. Letter D, we actually can skip as well because we didn't focus on letter D in class. Okay?
Sweet.
Alright, cool kids. Wait, pause. What is your goal, everyone, for
So
tomorrow?
finish chapter 9
9 and 10, come with questions. Yeah, okay, bye next.
Thank you. Appreciate it.
Hey, your test was a little bit more than what I thought. I used it.